basic definition, right? Rational function, anything in terms of talking about rational means that you can write it as a ratio or a fraction. Okay, so essentially if you take two functions of what we've been talking about, two polynomial functions, and put them on top of each other, like one over the other, you're basically creating a rational function. So any of the polynomial stuff we've been working with, and this is the reason it ties into the chapter, because you need to be able to find zeros of these rational functions to get some of the asymptotes. All right? It fits into here because you're taking both these polynomials, putting one above the other, creating essentially a rational function by making a ratio. All right? Your most basic one would be 1 over x. Right? Like the most basic rational function would just be f of x equals 1 over x. Okay? And if you remember, guys, the easy asymptotes and the one that most people remember are going to be the ones that affect your domain, which is anything that makes the denominator 0. And that's why finding the zeros of these polynomials is important with the graphing part. So again, everything that you've been doing basically leads up to this. So finding these real zeros are going to be what you need to do in order to get these asymptotes. All right? And your graphs, like the basic graph of the 1 over x, right, as they just sketched, would be something like that. There's x and there's y. Okay, so your graphs are going to resemble these, or should. You should have a portion where you've got a curve kind of encased within certain asymptotes. And with this one here, right, this graph, if you graphed it out, would never cross the x-axis, right, and would never cross the y-axis. It's never going to cross the x-axis because there's no way for me to make the value of this function, the y value 0. I don't have any number I can plug in there to make it exactly 0. I can get very close. I can plug in like 2 million there, and 1 over 2 million is very close to 0. It's not exactly 0, it's close. All right, at the same time, it's not going to cross the y-axis, because that value at the y-axis is where x equals 0, and I can't plug 0 into that fraction. It's impossible for me to do that, because if I plug in x equals 0, remember, it's undefined. Now, since everything we're doing related to sketching today, okay? There's about 5 steps I think I got written out here for you. All right. First thing you're going to want to do, guys, all the time, is go ahead and factor out numerator and denominator. The main reason to do the factoring, if you can, okay? I mean, this would be like, you know, if you can, do it real quick. Would be, as soon as you got something in factored form, you can pretty quickly find the zeros for like a numerator, maybe a denominator. And then a numerator is not too big of a deal. All right, so the main point of doing the factoring, especially to the denominator, is so that you can actually figure out what the zeros are going to be, because those zeros are going to become your vertical asymptote. Okay, so you would factor it out. The second thing would be find the x and y intercept. All right, of course, once you get it factored, it's probably going to be a little bit easier to find the x and y intercept. If you remember, guys, the x-intercepts, that's where y equals 0, or if you want to think about it as a function, it's where f of x equals 0. And the y-intercepts are where x equals 0. So if you just take 0 and plug it in, that's going to give you the y-intercept. Right? These things might not exist. Like in the graph of 1 over x, there's no y-intercept there. There's no x-intercept. That's fine. Okay? There are going to be times where you cannot find these. They just don't exist. All right? But if they do exist, you need to find them. Because I'll be looking for those things. Remember, guys, sketching doesn't mean you're drawing something that's 100% accurate. It's not going to happen. You don't have a, you're not a computer or anything. All right, but for sketching stuff, I am going to be looking for asymptotes, intercepts, that kind of thing. Okay? All right. Next thing would be vertical asymptotes. Okay, this is the zeros of your denominator. So again, we're going to have polynomials in there. Finding the zeros of a polynomial is the main point of the chapter. It's all built up to that. Being able to find those is going to enable you to then graph these. You need to be able to find the zeros of these polynomials in order to do that part. All right, and remember when you throw in the asymptotes, right? I like to do with like a little dash line, okay, to represent where they're at. All right. Next thing, the horizontal asymptote. This one, you just find whatever makes the denominator 0.
Oh, okay.
That's why if you go ahead and factor it in the beginning, you do it real quick. All right, this next one says divide everything by the highest power of x. What I mean is, you would look at your entire rational function in the non-factored form, like the original. You would see whatever the heck the highest power of x is, could be x to the 4th, x cubed, whatever. Okay. That should be L, that's not 1. And then you're going to take that and you're going to divide everything by it. Okay? The idea that is anything that is left with an x on the bottom, you ignore. Like 1 over x becomes a 0. This deals with limits, but we don't talk about really limits yet in here, so I'm not going to go into that right now. Okay? But essentially, when you do this part, you are doing something that talks about that limit. Okay? But it's going to be the same process every time. So once I do like 1 or 2, it shouldn't be that big of a deal doing the horizontal asymptote. All right? And the last thing is going to be sketching. And look, everything I'm talking about now is going to be dealing with rational functions where probably you're going to have a higher power in the denominator than on top. Okay? If it was reversed, if you had a higher power in the numerator, then you would also have a slant asymptote, but I'll get to that at the end. It's like one other thing you can add here. But everything that's up there right now relates to either having the exact same power on top and bottom, like the highest power being the same on top and bottom, or having a higher powered one, or a higher order polynomial on the bottom than the denominator. All right, so I've got, I think, like 3.
How old is that? 6. Nope. That's the age that I like little kids, and then I like older kids, but I can't. That age, but I think they know everything. Yeah. No, I don't like that. I don't like that. I can see it. We're a little bit more mature than that. No, we're not. We can hide that a little bit. Really old, and then funny act, like the fact that I was better than everyone else. No one's
Alright. You guys, back to this. Okay, going through all the steps that I would want you to do. Okay, I said first thing is you factor it out. Like I said, obviously you don't really need to factor this because you're just dealing with powers of 1. Okay, so that means you would go to the next part where I'm going to find the intercept. Okay, so the x-intercept is what would make y equals 0. Remember, in the y-intercept is what you get when you plug in x equals 0. When you're talking about rational functions, guys, understand that the thing that's going to make the actual value of the function equal 0 would be making the numerator 0. Because 0 divided by any kind of number equals 0. So when you do actually the x-intercepts, you're essentially taking the numerator and setting it equal to 0. Now the only ones you would throw out here would be a number that if you solved it out for it and you plugged it back in, made the denominator 0, you would not include it. Okay, because that would make the function undefined. Okay, but if I can actually solve that out and go, okay, x is negative 3 over 2. So right there, for x is negative 3 over 2, that's going to be my y-intercept.
Can that be your x?
I mean, what?
Can that be your x intercept?
So I'll plug it back in to get the actual value.
That made x. Yeah.
How many x-intercepts? What am I doing? Sorry, I'm talking about the x-intercept.
What?
I know. I'm solving it for the x-intercept, but I was saying y-intercept. Is that what I was doing?
Yeah. So that's the x-intercept.
Yeah. Well, it's right next to x-intercept. I don't know why I was doing y. I'm doing the work next to the x-intercept. I have no clue why I was saying y.
So it's the x-intercept, right?
Yeah, I mean, that's what I was.
So you can always do that. You can just make the numerator equal to 0, and that's your x-intercept.
Each way, like I said, the only time you would not include it is if it's a number. If I plugged it back in, it made the denominator also 0. Like if I solved at the top and I got x equals 1, I wouldn't include it because if I plugged in 1, it wouldn't work. All right, then for the y-intercept, guys, just essentially plugging in 0, so just taking away everything that's got the x's, so we get y equals negative 3. All right, so I got x-intercept and I got y-intercept.
You got issues with that.
I do. After that, next thing would be vertical asymptote. All right, so vertical asymptote here would be whatever makes the denominator 0. Take the denominator, it equals 0. So then my vertical asymptote is going to be at x equals 1. The horizontal asymptote, okay, in the description it said you're going to take the highest power of x, okay, and divide everything by that highest power of x. All right, so making it essentially like the highest power of x here is x to the first, correct? There's nothing beyond the x to the first power, right? So I'm going to take every term that's in there, divided by it. Okay, and what you're actually doing is you're seeing kind of what happens to numbers as these limits approach basically infinity and negative infinity. If you take a number and put it over x, and that x gets huge, 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 like to infinity, like 10 million, billions, whatever, it essentially becomes 0. So the way you find these horizontal asymptotes is anything that's got a number and then a variable on the bottom, you treat as a value of 0. 2x over x, the x's cancel out, you're left with 2. X divided by x is 1. A number over x, again, you treat as 0. So I can get a number here. I've got y equals 2. So I've got a vertical asymptote, but x equals 1, and y equals 2. I've got a horizontal. Okay?
What happened to 3 over x?
Anything, here's how you need to think about it. All right? Because if not, then I'm going to have to go into limits of how to find them. If you have a number, okay, and when you do this whole process of dividing by the highest power of x, if you've got a variable left in the bottom, like 3 over x is just 3 over x. There's nothing to cancel out on the top. Treat it as 0. What you're doing is you're seeing what happens to this number as x gets infinitely large. And like I said, just for example, a huge number would be like if I plug in a million in. 3 over a million is such a small decimal that it's essentially 0. Like if I had 2x squared plus 3x minus 3 over like 3x plus 4x minus 1, I know right then my horizontal asymptote is y equals 2. Because the highest power here is x cubed. If I divide everything on top by x cubed, I'm going to have a number over a variable, which I treat as 0. It's just so they get to have it look at it. If this was a cube term, if that was a cube term, it would become 2/3. Because 2x cubed divided by x cubed is 2. So,
So basically, if the power on the top is less than the power on the bottom, you don't have it.
well, you have one, it's just x. It's the xx.
Oh, okay, gotcha.
All right.
Oh, I have a question. What if you're left with an x when you're finding the horizontal asymptote? Like
Got
if
it.
you, like if somehow you put like
You won't be left with it.
ever?
There's no way. If you pick the highest power, everything will. Your two options are either going to be left with a number or something where a variable's in the bottom. The only way you'd be left with an x is if you didn't pick the highest power.
And also, you said you're putting it over x, but are you putting it over the power? Like, say that was, 2x plus 3 cubed. Would you, like, put it over 2?
Being like,
I mean,
if
or,
it was
I
like
mean, over 3.
parentheses like that,
Yeah.
no, then you'd have to, it'd be x to the third would be the highest, but you also need to expand that to do this process. Like, to do the horizontal asymptote thing, you need it in unfactored form. It has to be fully expanded, or else it's not going to work. Right? So if I gave you one like that, which I would highly doubt I would have it in that form, but if I did, you would have to multiply it all the way out, then do the whole dividing. All right, you wouldn't want to leave anything through the power. All right, so like, the last step, guys, because you got asymptotes here, I got intercepts here, would be to sketch it. Okay. What I would suggest you do, because you guys are always going to have the availability of graphing calculators, is to go to the calculator and check and see what it looks like. Like hopefully if you graph that in the calculator, you should see a graph that has the asymptotes where you wanted them and the y-intercepts where you wanted them. Okay, and it was 2x plus 3 over x minus 1. If I graph 2x plus 3 over x minus 1, you see that? Okay, which again, like I said, makes sense. Here's the x-intercept I wanted, that's negative 1.5. Okay? This one right here, that's the vertical asymptote where you wanted it. And the horizontal asymptote is right there, positive 2. Okay? Yeah.
Wait, but why did we cross the x and the y after?
We got x and y intercepts.
I thought you said it had more crosses.
No, the original one.
That's the basis for this one.
Yeah. No, this one here is based off of what we found. I mean, we got an x-intercept at, I think it was negative 1.5. 3 over 2. The y-intercept was at a negative 3. Okay, and then this is the vertical asymptote, which is the x equals 1. And then the horizontal one, that last one we found, is at y equals 2. Okay, it's just they don't graph, like most of the time the calculator is not going to graph in there the horizontal asymptote. But when you sketch this out, the things I'd be looking for, and again, the graphing calculator is just, the reason to do this part is just so you can see the basic shape of it. But if I'm checking this, like I'm going to be looking for you crossing that point there, you crossing that point there, having the one asymptote drawn in at y equals 2 and having the other one at that. And then going, oh, the calculator has a basic shape that's much smoother curve than that, but still. Okay? Like that would be fine. Like that whole sketch right there would be fine. As long as I see it crossing the intercepts, if they exist, and having the asymptotes in the correct spot, it's going to be a perfect graph. For what I want to see, for what the sketch is going to be. Next one is this. Okay, so again, I'm going to go through the process of finding everything. All right. The first thing, like I said, on all these is going to be you want to factor them out if you can. Okay. So if I factor out the bottom, well, or can I factor out the bottom? Yeah. So, in the whole purpose of doing the factoring part on the denominator is simply that when I go about finding my asymptote, it's already in a form where I can quickly find it. What's that factor out to? X plus 2, x minus 1. Okay? So it's factored, all right? I'm going to find my...
Wait, yeah, you got to the top, too.
No, I can take that. Because it wouldn't do me any good. The only time I'd want to do something like that is if I could divide out something on top and bottom. Like if I factored out 2 and it made something cross out, then I'd be more inclined to do it.
So if it was 2x plus 4, then you do it?
Then I would probably do it with 17. It would make it a simpler graph to work with, even though it's exact. Alright? So first thing we do is find the x and y intercepts. Okay? So x-intercept would be doing numerator equals 0. Okay. If I solve out 2x minus 4 equals 0, you get x equals what? 2. Okay. And that's okay. I can use it because I can plug 2 in the denominator and it doesn't give me 0. All right. This one here would just be plugging in x equals 0. So if I plugged in x equals 0, I'd be left with negative 4 on top and negative 2 on the bottom, correct? So, again, this is y equals. So here I get y equals 2. Okay, so I have intercepts, so I'd be looking for those. Okay, I would definitely want to see them. Next thing would be the asymptotes, so do the vertical ones first. All right, so the vertical ones would be taking that denominator, 7 equals 0. It's already, the point of doing the factoring, guys, is so we get to this point, you can just go ahead and say the 2 quick answers, which are, which 2 values make this 0?
Make it 2, 1.
2 and 1. There's my 2 lines, so I'm going to put asymptote 6. Okay? The other thing would be the horizontal asymptote, which I can already tell is going to be the x-axis, because that's where y equals 0. The reason is the highest power here is x squared, correct?
Yeah.
So if I take x squared and divide everything by it, all right, and then once I do this whole writing this out, I actually like simplify and divide things out, I'd be left with 2 over x minus 4 over x squared over 1 minus 1 over x minus 2 over x squared. Remember I said everything that's got a number on top and a variable on the bottom, treat it 0. Doesn't matter. Because it's still, I'm talking about this fraction getting small, small, small instead of bigger. So it's going to be 0. So it's just 0. But here's what you got to understand. This is y equals still. Guys, the line y equals 0 is the x-axis. Okay, those are one and the same. So if you get something like that where you see the higher power on the bottom and the lower power on top, the x-axis is always going to act as a horizontal asymptote. But here's, and this is going to get a little confusing in the fact that when you graph this, I am actually going to pass that. But this, the horizontal asymptote in this case is going to deal with extreme values of x getting extremely large and extremely small. Okay? All right, so I've got the main part of it is right here. Okay? This one right here is going to matter mostly on the rational functions like we had on the first one, where the powers are the same. Okay? All right, so if I take this, and again, what I would say is, you've got these points I'm going to be checking, and this process you have to do just in case you get fractions that aren't easily converted from a decimal to a fraction. Like I understand, guys, you could probably graph this and see the intercepts and see where the asymptotes are, but if I got like a vertical asymptote that x equals like 5/12, you don't know what the heck decimal that is, you're not going to be able to look at the calculator and tell. Because I want exact answers, I don't want rounded decimals. Okay, so you need to be familiar with this and make sure you can do everything that we did up. Okay, process-wise. All right, so I'll go to the calculator now. All right, just to check and make sure I've got everything correct. What was the top? 2x minus 4? And then x squared plus x minus x squared plus x minus. Make sure you group, guys, the entire numerator and denominator. All right? If I graph that, you get something like that.
Whoa.
Okay? Your two asymptotes are the little kind of slanted line. That's just, it's slanted in the fact that that's how the calculator has to deal with calculating those values.
That's not what I thought.
All right? We'll group it exactly.
Yeah.
All right? So if I went about graphing this now, your asymptotes we had at x equals 1, right? There's x, y. -2. There's my two asymptotes. And then what I would say is, and you know I've got the x and y intercepts, right? My x and y intercepts were both at a +2. So I know I'm going to have 1 point there it's going to cross, and 1 point there it's going to cross. The act of graphing this out, guys, is just so you get the shape. I know that in this part, I'm going to have a curve going that way. This middle section is going to go down through the intercept and then back up. Shouldn't touch that, you can push that curve more. And then if you look at this part, it comes down, goes up, and then it curves back down to it. So this part right here is usually what would get people on this graph. Because we've kind of said that the graph technically shouldn't cross
Whoa. You got totally
the x-axis, all right? But what I said, when we do that horizontal asymptote thing, it's only for extremely large values of x. So if I keep going into infinity, like this direction for infinity, like forever, it's never going to cross it. It's just going to get really close to zero. Okay? All right, so guys, this is the last bit that you have to add into. But the only cases where this thing is going to come up is that if the highest power in your numerator is larger than the highest power in the denominator. Okay? Then you're going to end up with a slant asymptote. All right? In order to do that, basically what you're going to do is you're going to do a long division problem. Okay? Or, and you're doing the long division with the denominator divided by the numerator. All right, so right here, we'll just do it, find a slant. Like, I want you also, we'll look at the graph in the calculator, and I'll probably sketch it real quick. But the whole idea with these is simply that, you know, if I asked you to sketch this, you would still need to see if there's horizontal asymptotes and vertical asymptotes and all those things. It's just the fact that if I saw this function, I saw that the power on top was a square and the bottom one was the first power, I know there's going to be a slant asymptote, because the higher power is on top. All right. So in order to do this part, we're just going to deal with the slant for right this second. Essentially what you're doing is you're taking the denominator, dividing it into the numerator. Now, you can do this with this problem right here. I can either set it up as long division, or I could do synthetic division, okay? So I could do synthetic if you want to do that, all right? So just making sure that when you do it, you change the positive to negative, negative to positive kind of thing when you pull it out, because you're dealing with zeros and X's. So if I did this, what I would do is I would essentially just divide it until I got those first two numbers. So that's all I need. Because the slant asymptote, guys, is a line. All right, so if I did it for this, that would be 3, that would be 8, I'd be done. I don't care if there's a remainder or not. Well, I do, because if there wasn't a remainder, like if there was a 0 for a remainder, then I would just leave it all the way divided out and understand that it's no longer a rational function, it's just a line. But in this case right here, I would see that I do have a remainder, right? So that means that I'm going to have a slant asymptote, and that slant asymptote is going to be this line, right? This line would be x plus 8. Hopefully you guys can graph the line x plus 8, right? That's the line at a positive 8, right? Y-intercept of 8 with a slope of 1. So up 1 over 1, so, all right? So the graph should fit within that round. Now, the other thing you would have to do, is find any of the other asymptotes that would exist, for the most part, with the vertical one, okay? Such as, if I asked you to do the vertical asymptotes here, right? The vertical ones are whatever makes that denominator 0, which is x equals 3. So I would go to 3, draw my other line. All right, so your graph would have to fit within those boundaries somehow. The vertical asymptote, remember, whatever makes the denominator 0. That still comes into play. All right, so here's the thing. I doubt anyone's going to sketch this without plugging in the calculator. Okay? So, if you took that, guys.
Don't you need to find the horizontal?
No. Alright? If I took what I just had, guys, and plugged it into the calculator, which is what, x squared plus 5x plus 4? And x minus 3. Okay? I graphed it out, it'd be something that looks like that. Obviously, I can't see everything. Okay, I know I can't. What I would say is make sure that you give yourself a wide enough range. If you, for any chance, think that you're not in range, change your window so that it might be there.
You just zoom out.
Yeah. Okay. And what I would say, guys, is
I don't have a second.
zoom out. What you'll see is you're going to have one curve that comes up, it goes down, the other one goes down, back up. So if I took that, and again, the graphing calculator should only be there to kind of guide you in what it looks like. If I went here and graphed it, it would look like this, and then there.
Oh my God.
Okay? All right, and guys, look, I would have done everything else. Like, I still need to do x-intercepts, y-intercepts, and all that stuff. I just wasn't going through the entire process there because I